All right. Okay, you guys learned in the last unit, we learned about basically lines. We learned about segment addition postulate. We learned about how to find the length of a line using the distance formula, right? We learned how to find the length of a missing side of a triangle, right? So we did a lot of work with lines and lengths of lines and midpoints of lines, okay, all things with lines. All right, so this new unit that we're starting on is all about angles, okay? So let's first define actually what an angle is, okay? So an angle is the space created between two rays sharing a common endpoint. Okay, so one of our first objectives that we're going to be doing today is just learning some vocabulary so we understand how to talk about these different geometric figures that we're working with. Okay, so an angle has something called a vertex, and the vertex is the common endpoint where the two rays meet. Okay, and the last part of an angle is the side. The sides are the individual rays composing the angle. Okay, so to give you a better idea of some of these things, I'm going to draw a picture up here, okay? This is what a ray looks like, right? You guys learned about rays in the last unit. It's an endpoint, and then it's kind of like a line, but it's not exactly a line because it only goes in one direction. Remember, we learned about rays? Okay, so an angle is the space created between two rays sharing a common endpoint. So if you have another ray, they have a common endpoint. This space created, this is the angle. Okay, angles are measured in degrees. Do you guys remember seeing that last year?
Yeah, I don't like those.
You don't like those. Okay, well, they're measured in degrees, okay? What degrees are is if you think about a full circle.
180.
You just love to shout out wrong answers to me all the time. A full circle doesn't have 180 degrees. It has 360, okay? Half of a circle has 180, right? Okay, so if we've got a full circle, right, 360 degrees, we measure an angle as if we were to take that full circle and divide it into 360 little tiny portions, okay? Let's say this angle were 30 degrees. That would be like 30 out of 360 degrees of the circle. Does that make sense? Okay, so anything less than 360 degrees is not completing a circle, right? Anything less than 180 is not completing half a circle. Does that make sense? Okay. All right. Now, this part here, the common endpoint, this is your vertex. And this part here is your side. And then this part here, this other ray is your other side. Okay? All right. Does anyone need more time writing or drawing anything right now? No? Okay. so let's take a look at the next one, okay? So for this next section, one of our objectives today is we want to be able to name the different parts of an angle, okay? And name them correctly with the correct notation. So when we're naming the vertex is a point. So if you look at where the vertex is, what point, what letter is representing that point?
D.
D. So we're going to call that vertex is point D, okay? When we're talking about the sides are made up of rays. So we're going to be naming two rays. So what's one of the rays?
D.
DE. Okay, so make sure you do it with ray notation, DE. Okay. And what's your other ray that you have? DF. Okay. So what I want you guys to do right now is I want you to fill out example 2 and then share with your shoulder partner what you got. Okay? Okay, so check your work. Did you guys get your vertex was B?
Yeah.
Did you get one of the rays was ray BA?
Yeah.
And the other ray was ray BC. Okay? All right. Okay, let's move on to the next part. Okay, how to name an angle. Okay, there are 4 different ways to name an angle. Okay? So one of our objectives today is to be able to correctly name an angle and write the name of the angle in correct notation. Okay? So when we're naming an angle, there's 4 different ways. One of the ways is by its vertex. Okay? So if I'm naming an angle by its vertex, what is the vertex of this angle?
Q.
Q. So I could call this angle angle Q. Okay? Another way to name an angle is by its number. Now you have to be careful when you're doing it by its number and really make sure that that number is not representing the angle measurement. How do I know whether or not this number 4 is representing the measure of the angle?
Because it doesn't have the little degree sign.
Yeah, if it was representing the measure of the angle, it would have a little degree sign, which is like a little circle next to it, right? Okay, since it doesn't have the degree sign, it's saying what we can name the angle. So we can also name this angle, angle 4. That's another way. Now, do you guys notice in front of the vertex and in front of the number, I put the angle symbol, which is like a slanted L, right? It's not like a exact perfect, it's a slanted one, okay? It looks like an angle, right? Okay, so next, there's 2 different ways that are both kind of similar, okay? This is by 3 letters. Which are basically by the letters in its sides. Okay, so this last one, this is like where you get 2 different ways using the same method because there's 2 different orders. Okay, so the first way I could name it is PQR. So I could call this angle PQR. The second way I can name it is calling it angle RQP. Now, could I name this angle angle QRP? No, okay? And here's the reason why, okay? You always have to put the vertex in the middle when you're naming it by 3 letters, okay? So the vertex is going to be in the middle, right? So we are not allowed to name this angle PRQ. We're not allowed to name it RPQ. The only letter that belongs in the middle is Q, because Q is the vertex, okay? So we can't name it with a different letter in the middle. Does that make sense? Okay. So here's what I want you guys to do right now. I want you to come up with 4 different names for this angle here. After you've come up with 4 names, I want you to have some think time by yourself. Then share with your shoulder partner when you're ready, okay? All right, let's come back together, okay? So, if I'm naming this by its vertex, okay, what is the name of the angle by its vertex? Angle F. What about by its letter?
7.
Angle 7. Then,
Wait. Didn't you say by its number?
Then, if I'm naming it by its 3 letters, what letter must be in the middle? F. Okay, so I could name it G, F, H, or
H, F, G.
Or H, F, G. Okay? How'd you guys do on that? Raise your hand if you got it right.
Oh.
Okay, cool. All right. Okay, let's go to the next thing that we want to be able to do today. Okay, so we want to be able to draw an angle correctly, so we're going to look at the things they gave us. They gave us the vertex and the sides, and we're just going to draw. Doesn't matter what size you draw your angle, just draw an angle, draw its vertex, draw some points for its sides, and then label it correctly. So what's the vertex? B. So put B in the spot where the vertex goes. What are the letters for its sides?
A and C.
A and C. So put A somewhere, put C somewhere. Doesn't matter where. Okay, can you guys really quickly do example 6 and then share with your shoulder partner? Let's go ahead and check what you guys got. Okay, did you guys draw an angle?
Yeah.
Did you label your vertex S?
Yeah.
Did you label your other points in the angle R and T?
Yeah.
Okay, perfect. Okay, the last objective today that we want to be able to do is we want to be able to tell different angles apart from one another, so to be able to classify them based on their measurement, okay? So we're going to define some of the different types of angles and draw a picture of each one, okay? And then talk about the differences between them. So an acute angle, does anyone remember what is special about an acute angle? Caitlin? Yeah, okay, so this is an angle that measures between 0 and 90 degrees. Okay, the reason why I say it's between 0 and 90 is because, like, in higher level math, sometimes they talk about negative angles. We're not going to be talking about negative angles, okay? But, like, if you said that you had, like, a negative value, we would not classify that as acute. Does that make sense? Okay, so you guys will learn about that, like, maybe when you get to IM3 or pre-calc.
Negative angles, like it inverts on itself?
No, so it more refers to, like, a direction when you're working with it. But, yeah, it is a thing, okay?
It's like my brain just, like, stopped for a second.
Okay. All right, so let's draw a picture of an acute angle. So think about what you know a right angle looks like and make it smaller than a right angle. Does that make sense? Okay. All right, now, we learned about right angles when we were working with Pythagorean theorem, right? So what's a right angle, Kennedy?
A 90-degree angle.
Yes, okay, so this is an angle that measures exactly 90 degrees. Okay, usually it looks like a perfect L shape, right? And in order to know for sure that it's a right angle, we either need to be told in the instructions of the problem that it is a right angle, or it will have what little symbol? Yeah, a little box, right? That symbol means that it's a right angle. If the picture doesn't have that symbol and the instructions don't tell you it's a right angle, you are not allowed to assume that it's a right angle, okay? Because who knows, maybe it's 89.9 degrees, right? Maybe it looks like a right angle, but it's not, okay? So you have to either have this symbol or have the instructions telling you that, okay? All right, let's go to obtuse. Do you guys remember what an obtuse angle is? It's greater than 90, okay? But also, there's another stipulation, okay? It's an angle that measures between (90 degrees and 180 degrees. Okay? All right, so it's an angle measuring between those measurements. Okay? Obtuse kind of sounds like the word obese a little bit. Okay, and if you think about somebody that's obese, they're kind of big, right? So your obtuse angles are your big angles. Does that make sense? That's how I remember it. Okay, so an obtuse angle is going to be larger than 90 degrees. So if we took this 90 and we started tilting it that way, right, we get an obtuse angle. Okay? Now, do you guys know what a straight angle is?
Yeah.
What's a straight angle?
Straight line.
It makes a straight line. Okay, so let's write down, though, this definition. It is an angle that measures exactly 180 degrees. So, you have a vertex. You've got a ray going one way. You've got a ray going the other way. This measurement here is 180 degrees. It's half of a circle. Does that make sense? Okay, that's a straight angle. All right. Do you guys have any questions about how to classify angles, how to name angles, how to draw angles? Anything about angles? Okay.